Good day and Happy New Year to everybody. You're all very welcome to the first Saturday technical session with me, Ian Cowan, the first session of 2025. We look forward to a successful year. Now, we have people just logging in, so I just want to make sure, because the speaker wasn't here a moment. He actually is here, but his video is not yet ready. So today we have an interesting lecture from Hans Deyssenroth. I hope I'm pronouncing his name correctly. I wanted to check with him before we started, but I didn't have an opportunity to. He's from Germany, and he's basically going to give some results from his analysis of data from lunar laser ranging, which he contends contradicts Einstein's what he calls ingenious space-time idea. So it's succinctly relatively wrong experimental facts. Okay, well, we have briefly discussed things like ranging, lunar ranging, and I myself have looked at things like ranging of the planets Venus, and experiments on looking at results from, say, Jupiter's moons, and the classical analysis, which were done by Romer. But Hans, now, let me see his video. I'm going to bring Hans up now. Hans, you're there, but you don't seem to have video operational. Can you hear me?
Yes, I hear. Can you hear me?
Excellent. I can hear you perfectly.
Yeah.
Could your video be stopped, your camera?
Oh.
If you look down.
I see. Yes.
Very good. Yeah, something's happening now.
Okay. And now?
Yeah, I only have a figure with a round dot.
I see. I
so
see.
Maybe the video is not quite working at the moment.
That's strange.
Yeah.
Usually the camera works.
Well, are you using the camera also for your audio?
No, it's the camera in the laptop.
Okay. Yeah, well, the audio is perfect, but the camera doesn't seem to be responding. We can do without it. It's not ideal.
Yeah.
If you'd like to try.
What could I do?
I don't know what to do. Sometimes
I go to the settings, maybe.
Yes.
Just a moment.
Okay, take your time. I'll just have a few more. While Hans is doing that, I'll just bring him down, actually, because his voice quality was excellent. So I think, I think we can deal with that. But it wouldn't be ideal. It would be nice to see him, particularly as he hasn't addressed us before at one of these technical sessions. And it was actually Jim Keane here who introduced him to me, which resulted in some further discussions, and hence today's talk. Okay, I'll just see if there are any no comments. Okay. Okay. Right. Sorry about this. Is there a variety of lunar ranging experiments? Well, we'll no doubt get a summary of those from Hans presently. Okay. Right. Okay. Well, Hans, I think we might have to forgo, seeing you unless you get it working during the talk. What do you think? I mean, if we started, because we're sort of eating into your time. I'll just actually summarize for everybody's.
No. Can you see my PowerPoint presentation?
No. So there may be a way out of that, though. Do you see? There's a bottom banner on your screen which would say mute, stop cam, settings,
Yes.
present. Right.
Yes.
Okay. Well, you have to present. You have to click present. You click present, right?
Just a moment, I don't see it.
You may have to hover your
start cam.
Your camera has gone mute again. I'm not sure if that means we can't hear you. No, you're back again. Yeah. At the very bottom of your screen.
Present.
Present. Yes, present.
Yes, present. Yes.
Just click on that.
Yeah, I have.
And then it should give you options: slides, extra camera, video.
Yes.
Share screen. If you click on share screen.
Okay.
It'll then give you another thing. Now, unfortunately, you have to do 2 or 3 things here. So you have to click on entire screen at the top right. Do you see that?
No, there's issues with 2 monitors sharing.
Have you clicked share screen?
No, screen sharing in issues with 2 monitors.
I'm not quite sure what that is. When you click present, it said.
Okay, well, I try it. Share screen.
When you click present, I'm sorry, everybody. We should have this sorted out in a few minutes. When you click present, what does it show you?
Share screen with at least 2 monitors.
Yeah, I'm a bit surprised at that, but because normally it gives you options. Anyway, click share screen.
Yes.
Okay. And what does it give you then? 2 monitors.
Okay, just a
Doesn't give you anything.
It's now working?
No, you'll have to get a screen, and it'll have to give you a possibility Chrome tab, window, entire screen, and you'll have to click entire screen. If you don't see that, there's some problem. Do you not see that?
I mean, in a different. Oh, that's great.
Let me see now. Okay. Maybe Hans just has to click the camera button at the bottom. This is what James says. Yeah, well, that's for his camera, but we're not. We don't even seem to be able to get his things working. There is another way out of this. If you have a file, say a PowerPoint file.
Yes, I have.
You can send that to me by email.
Okay.
And then I can present it.
Okay.
Okay. So let me see.
I have another. I have something in my ear which doesn't.
What do you?
I have another presentation in my ear. So that's. I have. It's clear. I hear the echo. I hear the echo.
Okay. Well, then the system is echoing.
I have to. I think I have to stop. It's too confusing.
Do you have headphones?
I will send you the file immediately.
Yeah. Okay.
Okay.
Are you using headphones or earphones?
Yes, I have. Yes.
Okay. Well, that normally helps, but maybe it's a hindrance. If you go rid of those, it might be better. I don't know, because the echo is very, very difficult to deal with. I know when I get it from some people, I find it impossible to deal with.
It's a complete mess. I stop and go in once more.
Okay, do you want to leave and come in again?
Yes.
Wait a minute, just before you leave.
I
Wait a
come
minute.
back.
There's something which you've put up. No, it's only. I think you've managed to share your screen. Sometimes.
Yes. I go to the settings, maybe.
Yes.
Just a moment.
Okay, take your time. I'll just have a few more. While Hans is doing that, I'll just bring him down, actually.
Okay.
Because I don't know where that's coming from. Quality was excellent. So I think...
okay. I think I have to switch off. Just a moment.
I do appreciate that we ought to have done this 10 minutes before the start, but that things like this happen. What can one do? Yeah. Yeah. Yes. Yes. I'm looking at some of the comments. He could turn the speakers down, maybe. But yeah, he joined it late. That's why he couldn't do pre-check. But when all else fails, just switch off, log out, and log in again, and sometimes it solves the problem. So I think he's doing the right thing at present. If he has this recorded on video, that's another possibility. We can play the video and then discuss it with him afterwards. We don't really need his image at that point. The only one good thing is that the sound quality has been excellent. People have been saying that. He hasn't come back yet. Let's see, is there any... He doesn't seem to have sent me his file as a backup. Yeah. Well, if I had a video, I think Quest has said you could play the video. If I have a video, I'm not sure if he has one. Right. I'm sure you mean clocks are affected by gravity. In other words, they're influenced by gravity. Affected means they're brought about by gravity. I'm sure that's a typo. They are certainly affected by gravity. Well, atomic clocks are. Atomic clocks. Okay. Some people having a side chat about time. But the speaker, he's disappeared, which is bad. One might have said we should have held on to him once we had him. You can always... What's the expression from King Lear? Striving to better oft we mar what's well. I think that's said by the husband of Goneril or something. Yeah, okay, he's taken the correction. Being a bit pedantic. However, Okay. I'm going to have to ask for help from a few of our people in the green room, because we don't want to be hanging here for 10 minutes, just wasting time. That's no use. So, Roger, you're up, but you're mute.
Hello.
And
Hello.
but Bob Gray, you're welcome. Actually, Bob, haven't seen you for a long, long time. And Denny is here. He's mute as well. Wait a minute. Just at this very moment, when I brought you all up, Hans has come back. So I'll bring you all down again. Maybe you're relieved of trying to help me out just for the moment. I'll bring you back presently. Let me see now. So Hans, you're up. Okay, can hear you. I think we're going to have to forgo any video. However, we mustn't forgo your presentation. You don't seem to have sent me your slide. Oh, wait a minute. You have. Yep. I've got it now. So
okay.
Let me.
So I suggest that you open it, and I speak the comments if you can hear me.
Yeah. Let me just try to get the attachment. You've sent it as an attachment.
Okay.
Here we are. So let me download that. So I have it on here. January 4th PP. Yeah. TX. Okay. Right. Let me close that so it doesn't interfere. Now, okay. So what I can do, if I can find where I've put this thing, here it is whenever you wish, you can tell me. I might give you a moment to introduce yourself. Maybe tell us something about yourself, just a word or two, because many of us don't know about you. And whenever you're ready, just ask me to show the slides. And what I'll do then is I'll share my own screen and I'll put it up. But you'll have to tell me when you want me to change a slide. Is that all right?
That's fine. Yes.
So
well,
Sorry, I'm going to disappear now and give you the complete screen, although we don't have your video.
Okay.
You just talk, and then when you're ready to show the slides, just say, we're ready now, put them up in, and I'll do that. Okay?
Okay. Yeah.
And I'll come back if needed, but I want to give you the complete floor.
Okay, my name is Hans Deyssenroth. I studied physics in Basel, worked in the pharma industry as IT manager, and when I was retired, I looked at physics again, and especially because my impression was that the theories of relativity are wrong. Therefore, I looked a little more in this direction. And finally, I analyzed the data from the Lunar laser ranging project, which is published, fortunately, and I saw that that is a problem because the data do not match with the theories of relativity. But it's a little bit complicated, and I would like to start with the Middle Ages and then show some more experiments which contradict the theories of relativity, and but these were ignored or dismissed by wrong arguments, and maybe you know them, maybe not, but I would start from the Middle Ages. And Ian, if you can present my first slide, that would be great.
I'll just come back because it'll take me a second to confirm to you that I'm working on it.
Okay.
Sorry, I think I might have said you're from aus Deutschland. You're from Switzerland.
Yes. Yeah, okay. No, well, I'm living at the border of Basel.
Okay.
This is Lörrach. This is a small town in the just next to Basel.
Okay. Right. I'll present my own slides, my own screen now. Hold on a minute. Now that's nice. Share screen. That's what we want. Entire screen. I don't know why it didn't work for you, but it should work for me. Share audio. I'm not sure. I have to make myself mute. Share. Now, if
yes.
so, can you see that, Hans? Your own
Yes,
slide.
yes.
Okay.
Yeah.
Well, then it means it's working. So
Okay.
I'm going to put myself down because otherwise,
Yeah.
otherwise you'll hear me. Because otherwise, it mightn't work. Okay. Okay. It's all yours now.
Could you please go to the slideshow up? There's up in the.
Actually, I can make the whole
Okay,
slide
okay.
fit the screen
Yeah.
without the banner on the left.
Yeah. Okay,
Okay.
doesn't matter. Doesn't matter.
Is that
Okay,
better?
yeah, that's fine. Yeah, that's perfect. I go to the Middle Ages because there the people were indoctrinated and convinced that the Earth has to be in the center of the universe. And here the planets circle around the center, and these centers circle around the Earth. And with this model, they could forecast and describe the paths of the planets in the sky. And here we can see that a mathematical model that is based on a wrong physical mechanism can provide exact results. They are in accordance with the observations and measurements, but it is wrong. And please, next slide. A mathematical model that is based on a wrong physical mechanism is misleading, leads to wrong conclusions, and prevents advances in physics and technology. Next slide, please. The funny thing for me is that we are in the same situation now again. In the quantum theory, we do not understand the physical mechanisms, and in the theories of relativity, there are there's a wrong physical basis. Okay, next slide, please. And the reason why the theories of relativity are wrong is very, almost ridiculous, because about 1900, Einstein and Lorentz did not know a little detail about the behavior of photons in a mirror at that time. That was discovered later by Richard Feynman. I come back to this point. Next slide, please. But it's hard to believe that the theories of relativity are wrong, because we have many experimental confirmations of the theory. We know the gravitational waves in the meantime, gravitational lenses, which are very important instrument for astronomers. But here already there's a problem, because the depth of the lenses in our next environment are not deep enough. The results of the experiments, of the observations, are not in accordance with the calculations by the general theory of relativity. We also know, thanks to the theory of relativity, that atomic clocks can tick slower or faster, And at radiation therapy, the electrons must be corrected to increased masses, otherwise this instrument wouldn't work. And in the accelerators like CERN, the theories are confirmed all the time. And the established physicists, they are bored if somebody criticizes the theories of relativity. And they think it's a waste of time to think about it, because there are so many confirmations. But next slide, please. How do we deal with an experiment that contradicts the theories of relativity? Can you accept it? Or is your faith so deep that you cannot accept it? Next slide, please. I will show you some experiments in which are not in accordance with the theories of relativity. I begin with Havlik Keating. These scientists traveled around the world with atomic clocks on board, and the idea was that these clock times are compared with a clock on the surface of the Earth. Next slide, please. When two frames move away from each other, and A sends a picture of his or her clock to B, then B concludes that the time in A is delayed, and if they move away from each other, there is a time dilation. And even if they move towards to each other, there is a time dilation. And this is due to the fact that the light speed is finite. But it's clear that these clocks in the frames do not tick different. It's only because it takes some time until the information is at the other frame. And this is an observation effect. Next slide, please. But now it was a great surprise, because the experiment showed that the atomic clocks ticked really slower. And that was unexpected, and even Einstein was astonished. And you see, this has nothing to do with the transmission of the clock time to the observer. There is, I assume, interaction of the atoms of the clock with maybe the gravity field or with the dark matter, I don't know. And the funny thing is, in order to get in accordance with the formula of time dilation, the observer had to be placed in the center of the Earth or over the North Pole. And this is not in accordance with the basic design where the observer is on the surface of the Earth. Okay, next slide, please. Another experiment that contradicts the theory of relativity. Maurice Allais, an economist and Nobel Prize winner, detected during he observed pendulum, the Foucault pendulum at a solar eclipse, that it changed the direction. And this cannot be described neither by Newton nor by Einstein. And my personal idea is that gravity can be nonlinear fielded. And the next experiments confirm this idea. Please, next slide. an astronomer from South Korea observed the behavior, the dynamic behavior of galaxies in a galaxy heap, the Fornax galaxy heap, and he came to the conclusion that it only can be described by the MOND theory. This is a a modified Newtonian theory. And the big advantage of this theory is that no dark matter is necessary to describe the rotation behavior of the outer stars in a galaxy. And this was also observed for white binary stars, stars that are in a great distance from each other. And here, the MOND theory can also be interpreted as nonlinear shielding of gravitation. Next slide, please. The idea of shielding gravity came from Eugene Podkletnov. He detected by chance that over a fast rotating disk, the gravity was lower. And the interesting thing, even in the floor above, they could measure that the gravity was lower. And his first interpretation was that gravity can be shielded. But this was under great discussions, and they tried to find another interpretation. But anyway, I think this is the most, or this is the best interpretation. Next slide, please. The most important, or no, one of the most important experiments which have been ignored completely were the experiments with Nina Kulagina. She was a Russian soldier who was injured heavily, also on the head. And one time, one evening when she was very angry, a can on a sideboard flew in her direction. And she realized that she caused this effect, and she trained it, she practiced it, and finally she could move small objects without touching them. And she was examined by many scientists. Also the EEG showed high activities. And they looked if this can be used for military purposes. But one evening, she was surprised by scientists who intended to show that she used a trick, that she cannot do that. And he brought his own experimental set with him and the cameraman. And then, please, next slide, they demonstrated it. And the question is now, how can she do that? She used no thread, no magnetic. This is anyway not possible with these matches. And the scientists were completely confronted with a mystery. They had no explanation for that. And therefore, please, next slide. Next slide, please. Ian, can you please? Doesn't it work?
Hans, I'm sorry to interrupt, but your sound has disimproved. You're breaking up a bit, and you're actually gone silent now.
Okay,
We can't hear you at the moment.
go off the blank button. Maybe it goes further on the arrow at the right.
I don't know if you did anything different, but it started in the last. Everything is frozen.
Oh,
Well.
that's great. Maybe you press
Oh, you're
the
back. You're back.
escape.
Okay, I can hear you now.
Yeah.
However, you're
Anyway.
breaking up again.
Huh. Can you go press escape and start from the beginning?
I'm only hearing a little of what you said. Did you say press
Okay.
escape?
Yes, press escape and start from the beginning. Or the space bar, or the arrow at the right
You
to
were
the right
breaking up.
side.
I can't really hear what you're saying. I'm not sure if you're giving me instructions or you're just talking to the slide. It's sort of breaking up very badly.
Yes, okay. Okay, thank you. Okay, the physicists at that time they were confronted with this experiment, and they were very creative. They invented a paragraph and said physics only can accept experiments that can be repeated in other labs. Therefore, these experiments with Nina Kulatrina were dismissed. But think about it. If you can accept that Nina Kulatrina could do that, then we have here an experimental proof that complex electromagnetic processes can either create gravity or what I assume field gravity. And if we look back to Petkov with the rotating disk, this is a rotating system, a periodic system, and the brain can also create periodic processes. Therefore, I assume that time crystals possibly could field gravity. Therefore, I suggest for all who work with time crystals that they should look if they can detect a gravity effect. And if yes, you become billionaire and even more, because this was a huge technical step. Okay, the next, please. The technical transformation of this psychokinetic effect into a technical application you can see here. This UFO you cannot dismiss anymore because and it's no fake. And this can control gravity and it can and inertia, and it can create a very, very cold environment about this object. By this, it can prevent supersonic bang. But this cooling technology is new and would also bring billions of dollars. And as it is not on the market, I assume that it is an alien technology. And Next slide, please. If I say alien technology, that means that aliens can be here. And this is rejected by the normal physicists because they are convinced that the light speed is the maximum possible speed. And this is not true, because in the 80s, a German physicist, Günther Mintz from the University of Cologne, sent a signal through a tunnel and through the air, and he remarked that the tunnel signal is faster. And he could transfer a symphony of Mozart with a 7-fold light speed. And later on, he toured through the universities with this experiment on the display here and demonstrated it. But nobody could believe him. This experiment shows clearly that light speed can be faster, and the belief or the faith in the theories of relativity is so deep that almost nobody could accept it. And all those of you who work with big computer systems where the transmission velocity is limited by the speed of light, I recommend take a microwave tunnel, then you can transfer information with a 10-fold light speed. Okay, next slide, please. Anyway, I try to find an experiment which can be accepted by the established physicists, and when I saw this drawing of the Michelson-Morley experiment, I saw immediately that this must be wrong. But why? Next, please. Next slide, please. If a tennis ball hits a board that is tilted by 45 degrees, the tennis ball will be reflected perpendicular. But if the mirror is moving, then the path of the tennis ball will be oblique. Next slide, please. And Einstein, in his famous 1905 publication, was also convinced that the path of the light of the photons from this 45-degree mirror must be slower by c square minus v square, and later on that there must be a time dilation. Next slide, please. I added here the gamma, which is the Lorentz factor, what you know, I think. And in the Michelson-Morley experiment, the time in the y-axis and the x-axis must be the same to save the null result. But we see in the x-axis there is a gamma too much. And Lorentz came to the idea that one should replace L, which is the distance you see here, divided by the gamma. If one does that, then the times are equal and the null result is null all the time. And here we see that Einstein came to the idea that if time and the length of the space is connected by the velocity, then time and space must be connected. They belong together. But if this is not the case, then the space-time idea is wrong. And okay, next slide, please. I came to this idea because I remembered a conclusion of Feynman. He said that photons in a mirror are not reflected. And this is really crazy, because if you look at the mirror, we think that we see reflected photons from us. But these photons are absorbed by the atoms in the glass, and after a short time, which you can see at this bold lines here, after a short time, new photons are emitted. Next slide, please. And new photons, that means that one can interpret such a mirror as a light source. Next slide. Then we remember Einstein's second postulate that says light is propagating independently of the velocity of the light source. And therefore, in my opinion, the photon must behave like in the next slide. Next slide, please. The photons do not get a momentum in the direction of the movement, but they can miss the detector at the bottom of this. Now, the question is, how can I prove this consideration, my idea? Next slide, please. Now we have the same problem as before with the video. Could you try to get the next slide, please?
Hans, I think we're
I
losing
cannot hear you.
bandwidth problem. So
Yeah.
may I go on to the next slide?
Yes, please.
And maybe you can talk about this then. I can't hear you at the moment. It's breaking up.
Okay.
Okay.
Then I remembered that there is the moon laser ranging project where they measure the distance of the moon from the Earth with the accuracy of millimeters. And fortunately, these data are published. And so we have now the situation in the textbook and the theory of relativity is the light source of the mirror on the moon, which is the light source now, emits photon, they get lateral moment, and they arrive with dispersion, of course, on the detector on the Earth in the lower part. Next slide, please. And my assumption is that these photons appear at that location where the detector was 2.55 seconds before. And they can hit the detector, but not in the full size in this situation. But imagine if the blue arrow is up perpendicular to it, then there would be no displacement, because then the moon-Earth axis would be in the same direction as the velocity of this system. And the formula for this displacement is simple. It's v, the velocity, times the time, and depends now on the velocity of the Earth-Moon system in the universe. Next slide, please.
You're breaking up a little again, unfortunately. Seems quiet now. We can't hear
Okay.
you.
Can you bring the next slide?
Shall I?
Yes, thank you.
Okay, I think it might be a problem with certain slides. We can hear you now.
Yeah. Okay, fine. When I read the articles with the lunar laser ranging, I was surprised because I saw that only 10% of the expected photons arrive in the detector. And that confirmed my consideration already a little bit. And so I continued, and fortunately, Tom Murphy, the leader of this project, published the mean value of the return rates for some years. The next slide, please. And when I saw that, I was very surprised, because why should the return rates in September be 10 times greater than in May or in January? And why are there such peaks? And this reminds me to a superposition of sinus functions. Therefore, I came to the idea that I add the displacements of the various velocities of the Earth. Next slide, please. And there we have the rotation of the Earth, and the Earth orbits around the Sun. The Sun system moves to the apex. Our galaxy is rotating with a certain velocity. Our galaxy is moving to the atomic galaxy, and the local group is moving to the great attractor. And then I added all these displacements and started at the vernal equinox, and the beta in this formula is the angle of the velocity direction of the Earth in the universe, and alpha is the angle for the months, for the different months. Next slide, please. When I saw this, I was shocked a little bit, but in a positive sense, because it seems to be a very good correlation, but not perfect. And I asked me why, and then I realized that one velocity is missing, and this is the velocity of the great attractor in the universe. Then I was looking for it. I entered, I tried to find the right velocity and the right angle by trial and error. Next slide, please. And finally, I got this correlation, and this is really amazing. And if a physicist tells you that he got such a correlation, something must be wrong. But I added, I forgot to say, I entered the sum of these displacements in a Gaussian distribution, and in the same distribution which is also used by the Lunar laser ranging team in order to calculate the dispersion. Anyway, now I see I'm right, but I was afraid that a defender of relativity could disprove my considerations, and this is very easy. One only has to shift this structure by 1 or 2 days, then the correlation would go to under 50% of the zero. So it depends very much on the time when this pattern starts. Anyway, then I analyzed the daily return rate. Next slide, please. And when I saw that, I was shocked. Here, I selected those years where the Earth-Moon axis points in the same or in about the same direction, with a difference of 4 degrees. And this would simplify the calculations, because I only need tangential velocity and the velocity in the component in the north-south pole direction. Anyway, how can you explain this pattern? Why are the return rates so crazy? I think nobody could explain this by weather or by dust or whatever. And I believed not that I can do that with my addition of displacement. Next slide, please. But then I started in January and I was surprised. I had a good match with 2 peaks. Next slide, please. And again, a nice match. Next slide. And here I was overwhelmed. This is unbelievable. And if you look at the peak in the middle, this shape of the peak is extremely sensitive on the least of the smallest changes of any parameter in the sum of this displacement. Next slide, please. So I continued, and I always found very good matches. Next slide, please. Next slide, please. And here, this is the summary. Here one can see that there are fantastic correlations just by adding the displacements, which in great accordance with the experimental found data. And the probability that this could be wrong is smaller than 10 to the power of minus 80. So that's pretty sure. That is the best explanation for this, like random looking return rates, which were measured. Next slide, please. If you look now at the Michelson-Morley experiment, then it's clear in the case when photons are displaced, there is no oblique light path to the upper mirror. But this is perpendicular and independently of the velocity. And therefore, the gamma must be 1. And the time must be 2t, which is 2 times the normal velocity. And L divided by c. Anyway, in the horizontal axis, the length contraction cannot occur because the length contraction would destroy the null result. And in this case, the space do not change. And there is no more connection between that time and the space. And from the Havlik-Keating experiment, we know that clocks can really tick slower. And if this is the case here, we have again gamma in the y-axis and gamma in the x-axis. But these are additional and not connected with the gamma which was derivated from the Pythagoras. Next slide, please. So the photons that emitted from a mirror do not get a momentum in the direction of movement. And it is wrong to derive a time dilation by the Pythagoras theorem. Therefore, the light clock is wrong too, and the light clock is a pedagogic tool to introduce students into the time dilation. At the Michelson-Morley experiment, the Lorentz contraction destroys the null result, I explained, and the Lorentz transformation cannot be applied here. Therefore, Einstein's space-time idea is wrong, and gravity must be explained by a different model. And as I mentioned, I assume that gravity can be filtered, and this is a completely different model on which one can work in the future. And it shows also that the control of gravity and cooling technology, as we can see in UFO, is not possible if we stay with the existing theories of relativity. Okay, that is it. Thank you. Next slide. Thank you.
Thank you. Okay, let me see, can I bring it back now? I want to hand back to you, Hans. So first, get rid of that. Then I'll stop sharing. See. I thought I could do that directly. See now, how do I stop sharing? Screen sharing was cancelled. Make sure you click share. Yeah, I think I've automatically got it. So, so I take it, for example, you're not seeing my screen now. I have cancelled
it. Yes, that's right. Yeah.
Very good. Well, thank you very much, Hans, for finishing just after the hour, which is quite exceptional, considering that we waited 10 minutes at the beginning. Thank you very much. And you didn't rush anything.
Yeah.
You spoke clearly and slowly. And we only lost your voice once or twice during, I think, some of the video slides. Now, you forgive me because I didn't mention this in detail at the beginning, but I normally scan through the comments which have come in through the social media, Facebook.
Okay.
And maybe if there are any questions there, we can put them up and get you to address them. We'll only spend a few minutes doing that. But the problem is that I haven't been able to look at those because I had my screen entirely
Yes.
devoted to the
Yeah.
slides.
Okay.
So I just
Yeah.
look at those very, very quickly, and then we can
Okay.
put maybe one or two questions to you.
Yeah. Okay.
Most of the time, they're just conversation between people, so we don't have
Yeah.
to deal with them. But then
Okay.
we'll bring some people in from the green room to have more of a discussion, and then somewhere. So let me just see. Are there any points there that we want to put directly to you? Okay. Right. We're still just concerned with mechanics of getting the thing working, so we don't have to worry about those. Yeah, okay. Actually, this is something that had occurred to me, but Quest has said, I just read a paper, most of a paper, that shows that the Haffel and Keating experiment was quite fabricated. I think Kelly in particular has looked at the original data which he got from the US office in Washington, D.C. and hadn't been published actually. But have any views about that? You know, do you think that the data presented in the 1971 paper can be trusted, Hans?
Well, I only know the original paper, and well, what does fabricated mean? I don't know. I trust the people that they could read the atomic clock displays correctly.
Yeah, well, you're more noble. You're more trusting, but Alf Kelly. So he says in this paper, which I think Quest is referring to, obtained the original data, and there were a number of disturbing facts. He found that the clocks were drifting relative to calibrated atomic clocks on the Earth. They were moving all over the place, and
Yeah.
one clock was so bad that actually it should have been thrown out. There was some error in it, but most of the readings were actually based on that one clock.
Okay.
And then he found that the original results would actually be meaningless. The average, for example, would mean that there was no difference between the East and West.
Indeed. Yeah.
So they got a result by altering the data. That's what he means by fabricating. They sort of,
Yes.
so Kelly says, he said, well, look, they got this, they said, oh, this clock was drifting far too much. So let's take the one that wasn't drifting so much and assume it was in that direction. And they actually got the results that they wanted. So he's very skeptical about the whole experiment.
Yeah, okay, I cannot trust that. But I know that these experiments were repeated and they came to the same result. That clocks can really go faster or slower with high velocities, or faster if the gravity is lower.
Certainly, we know that. I mean, we know it by the working of the GPS that atomic clocks are affected by velocity.
But this has nothing.
And also gravitational potential. But so I'm not saying that that's nonsense. I say that is true. It's been proved experimentally. But if you accept Kelly's results, he says that this particular experiment, H and K, which is frequently discussed, is actually an experiment that should be thrown in the trash can. So he says.
No. Okay.
Discuss. It might come up again. I'm just still scanning this for somebody's shoveling snow out there, which I could be doing. We do have some snow on the ground here, but anyway. Well, again, Quest has raised something of this nature, but perhaps a distinction has to be made between the physical behavior of atomic clocks and a postulated time dilation. Because many, including myself, might say that time dilation doesn't exist, but atomic clocks do do run slow, or they dilate, if you like, with
Well,
increasing speed.
as I explained at the beginning, the time dilation exists if a clock information, let's say a picture of the display, has to be is sent to another frame. Then, if you remember these A and B frames, if B gets the picture of the clock display from A, he concludes that this time is delayed, and this is a delay of time. And if these frames move away from each other, this delay is increased. So we have really a time dilation, but this is an observation effect. And the time dilation, which you mentioned, by slower going clocks, well, this is obviously due to an interaction with gravity field or dark energy or what I don't know.
So, would you have any problem
I
in
don't hear.
calling it
Yes,
rather?
yes, I hear you. Yes, now I
Can you
hear
hear me?
you. Yeah.
Okay. Would you, Hans, have any problem in calling that rather a clock dilation, or a clock retardation, rather than
Well,
time? Time doesn't change, perhaps.
yeah, clock time dilation would be the correct expression,
Right.
because a pendulum clock would run differently like an atomic clock.
Oh,
And
okay. That's
I think
interesting.
this is a interaction, in my opinion, of the atoms of the clock with the gravity field, or with the dark energy. And this interaction was never considered, because the defenders of the relativity, they use this formula without thinking deeper how this clock time dilation comes together.
Okay.
Ah,
Just something on the shielding of gravity, which you mentioned.
yeah,
Do you conceive of the gravitational force in a different way, following your demonstration of its shielding? I mean, do you consider it as particles, gravitons, or do you consider it as a push-pull mechanism, or you can consider it as a wave motion? Have you any
yeah,
provisional idea?
that's a very interesting question, because we have to look for another model. And I am a fan of Fatio de Dillier, who had the idea that gravity can be explained by pushing particles. And he went to Newton, and Newton laughed at him and said, "No, gravity is made by God, of course." And that was the whole story of this idea that this pushing particle cannot work, because the Lesage theory, which came out of this idea, was rejected by at least 7 arguments. But if you look at these arguments, they are all wrong, except of one. And this says that these particles must be moved with a high superluminal speed. And this would fit to the observations in the quantum theory. But anyway, one should, in order to understand gravity, far below the quantum world. The quantum world only describes mechanisms and processes in the deep underground, which we should understand first. My suggestion is to regard the elementary particles as huge structures. I assert that every property is based on a structure, and the elementary particles have many properties. And therefore, elementary particles must have a very complex structure, and they can pulsate, oscillate, and by the way, one of the most important questions in physics, I would say, is the question, how do particles move? They have no legs, no wings, and no recoil. And the simplest answer to this question would be they are pushed by pushing particles. And the structures can shield all possible forces by structures which can asymmetric or symmetric, and elementary particle can consist of thousands or million asymmetric structures which can change the directions. And this is a completely new world, I would say, and I try to write a paper in the next years. But the problem is, in 3 weeks I'm 88, so I hope that I can get a paper together in the next years.
Well, you're doing very well. Thank you very much. I've completed looking at the general comments. I'm looking at the private ones now. Some of them have been saying that they could hear you perfectly, and actually it was I who was breaking up. Anyway, I hope you can hear both of us now. Jim Keane and Bob Gray have some questions here, and so does some comment made by Jim Morrison and so on. So I might just ask some people if they'd like to come up and talk directly. So in the green room we have Roger Anderson, Dennis Allen. Just as I mentioned Dennis, he put his hand up. So I'm going to bring you up, Danny, now.
Well, you're.
So any point you'd like to?
Hi, Dennis.
Hi, Ian. Ian, your work shows that light travels at different velocities too, doesn't
it? Once more, please.
So what Danny has said is that my work it also shows that the light travels at different speeds, if you like, different velocities. Yes.
Your work is related to Hertz rather than Maxwell Heaviside.
Indeed. And there have been some discussions about that recently. So we could put that point to Hans, if you wish, Denny. The Lorentz transformations were a bit of an artificial construct because you were working from partial time differentials in the Maxwell equations, which really didn't give the complete picture because you need to use a total derivative, which includes the convective term, which would always be used in sort of like fluid mechanics, for example. And if you do that, because Hertz did this, so we talk about maybe Maxwell Hertz equations modified to include total derivative. Well, then you find that the Lorentz transformations are quite unnecessary. Galilean transformations provide the necessary transformation. So I think that's what you're referring to, Danny. Did you understand what we were trying to say? Quite quickly, Hans. We were saying that this business with the Lorentz transformation is just really a quick fix, which is necessary if you're starting from incorrect premises, which are that the simple expression.
Well, as I showed,
or the heavy side.
Yeah, as I showed, the Lorentz transformation cannot be applied, at least to the Michael-Morley experiment, because there is no length contraction. And now, if we see that the time dilation is derived from the Pythagoras and not by the interaction of atoms with dark matter, dark energy, excuse me, dark matter doesn't exist, then this Lorentz transformation is wrong. And we have to find another solution for the Maxwell equations.
And in the MMX, I note that you have expressed the vertical return time as, say, 2L over C,
Yes.
which is what actually Michelson did first. And he was correct, if you like. They said, no, he shouldn't. And well, I would perhaps maintain that it is only approximately that without the lateral movement because of ether entrainment. That's the expression I would perhaps use.
Yes.
Yeah. Okay. You probably wouldn't disagree with that. I mean, if it were perfect ether movement of the
I would have some. We know that the vacuum is not empty. There are many ideas: the vacuum energy, the dark energy, and if we assume that is something similar like the ether, then these interactions would provide all these effects that you can measure.
Well, that spurs one other point I had noted here, which perhaps I could bring in because it's relevant to what Denny has raised and we're talking about now. You gave an example where if the microwave light speed could be 10 times C or something in these conditions. Now I'm just wondering, again, I mean, in my system, you can have forces which are, 10 to the 20 times C. There's no problem with gravitational interaction might or electrostatic fields. But I'm talking about equivalent to compression and rarefaction in an ether, like analogous to sound waves. Well, then you get a relationship between the magnetic permeability and the electric permittivity, the sort of Newtonian speed.
Yeah.
So, and that would come out. So if you have these purely transverse waves, you get C, let's see what we call C, the celerity and speed of light. Longitudinal waves, quite a different matter. Electrostatic interaction, quite a different matter. So I'm just wondering, if these microwaves are going 10 times this value, how is that expressed in terms of, etheric properties?
I have no idea. Because the measurement shows that the signal comes earlier. I have an idea that beginning again with these pushing particles, if elementary particles are pushed by superluminal pushing particles, then the elementary particles have also superluminal speed in the quantum world, but only for a short time. And when they can pulsate, they can possibly change their direction and can go back and forward so that the mean velocity is just that velocity which can be measured. And I assume in the tunnel they cannot pulsate, and therefore they are pushed with full high-speed velocity through the tunnel. This would be my explanation, but this is only, how should I say,
right, it's a quantum mechanical tunneling.
Fantasy. Okay. Yes, but it must be a reason. And by the way, it's not only light that can be tunneled quicker, but it was measured for electrons as well. They also can tunnel with superluminous speed.
Okay, so Denny, anything else before we just move on?
Well, those spiky graphs that he had, it seemed to, from what he was saying, it sounded to me like this could be Earth-Moon locking, which is the term you introduced.
I in German,
Locking.
Jan, could you repeat it, please? I understand you better.
I didn't understand. Did you say blocking or locking, Earth Moon?
Locking.
Sorry, didn't. Yeah, I thought you did. You're locking. Yeah, locking. Tidal locking. Yeah.
Where the ether is entrained in between the moon and the Earth in certain circumstances.
Yeah.
So that ties in with what he was saying, but I can't be sure.
Yeah. You ideally, if there were no locking, you would get, and experimentally we verified this, a zero drag on the ether in respect of the Earth rotating, the Earth spinning on its axis.
Okay.
But you don't get absolutely zero because there's a tidal locking. I think this is what Denny is probably referring to. Yeah. Okay. Well, unless you disagree with that or anything to add, maybe we can move on, Denny. Thanks very much for that. Thank you, sir.
You're welcome.
Okay.
Thank you.
So there's a couple of interesting points now, but Jim Morrison actually has raised a couple of points, in particular about Daniel Gazzari's paper on lunar laser ranging. So maybe, Jim, I'll bring you up to put those points directly to Hans rather than my. I can't even put them up from the private chat because I don't have the facility. But so you're up now, and you've also raised a point about maybe repetitions of H and K.
Okay. Hi, Jim.
Hi. Can you hear
me?
Sorry
that I'm here
Perfectly,
without picture.
Yeah. Are you familiar with the Daniel Gazzari's paper that he posted on Archive back in 2009, where he analyzed the time of flight of laser pulses sent to the lunar reflectors put on the moon by the astronauts, and found that the rotation of the Earth affected the essentially the response time by up to 200 meters per second. Just wondering if you'd ever seen that paper.
In my analysis, I saw that this rotation has absolutely no influence. It's too small in comparison to the speed of the local group, which contains several galaxies, including our galaxy, to the great attractor. This is about 600 kilometers per second. And so the rotation of the Earth is almost nothing in this analysis. So the interesting thing is that the effects that one can see in the return rates is influenced very much from this high speeds of our Earth in the universe. That means with the galaxy and within the galaxy and so on. But even the orbit around the Earth, around the Sun, is no big contribution to these correlations which I could show.
Yeah, what do you mean by return rates? I missed that.
Okay.
Sorry.
Okay, they send a laser beam to the mirror on the moon, And this laser means these photons have a special signature. They have a special color and they have a special time distance. And the mirror sends the photons back to the Earth, and the detector is near to the laser. And as I mentioned, from this mirror, new photons come back from the moon. And there's an interesting story. When there is full moon, the atoms from the mirror on the moon are so busy to emit new photons that they cannot emit all photons which have been sent from the Earth. So there are photons lost, and therefore at full moon there is a lower return rate. But this effect is not so big that it could influence the correlations that are showed.
And you have a paper that discusses this?
Yes, if you look in the Journal of Physical Mathematics, you will find it. You have to enter my name.
Did you post it on ResearchGate? Because I saw you're on that, right?
Yes.
Okay, I'll look there.
Okay.
Very good. Thank you.
Thank you as well.
Thank you, Jim. I've just noticed a question because I'm just corresponding with one or two people here. No, that's the wrong one, actually. Sorry, it's moved on too quickly. It's just a quest again. It's just from an elementary point of view. How does lunar ranging disprove special relativity? I don't necessarily mean that it doesn't. I just don't understand how. So I think your thesis, Hans, has been that lunar ranging has shown that the basic theory behind the MMX or the null result or the very small result has been incorrect. I think that's your thesis, isn't it?
Okay, I try to explain it once more. You remember the tennis ball, the reflection of the tennis ball. When the tennis ball hits a moving mirror, the tennis ball gets a momentum in the direction of moving. And this is an oblique path of the tennis ball. And Einstein and Lorentz believed that photons also get this momentum in the direction of moving. Therefore, the light beam from the 45-degree mirror to the upper mirror is oblique. And from this, the time dilation is derived by the Pythagoras. And the whole theory of relativity is based on this derivation of the time dilation by the Pythagoras. And in the Michelson-Morley experiment, Lorentz came to the conclusion that there must also be a length contraction in order to save the null result. And I showed that the photons that come from the moon have no momentum in the direction of movement. They go straight to this location where the laser sent it or emitted them. And therefore the path in the Michelson, the light path in the Michelson and Morley picture is straight up perpendicular to the laser beam. Anyway, the Pythagoras cannot be used to derivate the time dilation. This must be done by interaction of atoms with, I don't know, dark matter or the non-empty vacuum, let's say, non-empty space. And yeah, that's it. It's very easy. And Einstein and Lorentz did not know that the photons do not get a momentum. And therefore, they were sure that the light beam must be oblique from the 45-degree mirror to the other mirror. And yeah, that's it.
Okay. So actually, basically, you're not saying that
Ian, I don't understand you. You must activate your microphone first.
Is my volume too low or too high?
No, it's okay. But when you start to speak, the mic, I cannot hear.
Oh.
It takes about 2 seconds or 3 seconds when I hear you.
Oh, okay. Well, so if you just hold on and I'll try to speak more slowly. It was just a comment, really, Hans. I was just saying that you don't say that Einstein and Lorentz did not take into account a sort of a lateral movement, and that was erroneous. I have heard that said. You say, no, they took it into account, and that is an error.
Yes. They took into account that photons get a momentum, lateral momentum in direction of the speed of light, speed of
Hans,
the body. Yeah.
James Keane has asked about the peaks matching, and he wasn't clear on what data set this was related to. And he was asking, is there a paper on this? Now, I understand there is a paper, which I think I've looked at one of your papers. So,
yes.
Jim, with your permission, I'm bringing you up so you can put these points directly to Hans, or anything else if you wish.
Well, I just noticed that the peaks on 2-day data sets were matching in a rather remarkable way, and was wondering what I wasn't clear on what the 2 data sets actually were, and perhaps that would be clarified if there is a paper on that.
Hi, Jim. Nice to meet you here.
Hello,
yes.
Nice to see you, Hans.
I did not quite understand your question. Do you know why these peaks are, why the correlation is so excellent?
No, I don't. I was asking basically what the 2 peaks were, what the data sets are.
Okay.
I'm sure you explained that, but I just didn't catch it. Maybe if there was a paper on that, I could look at that, because that's an extraordinary correlation that you show.
Yeah, exactly. The peaks, what you have in these are the return rates of photons from the mirror on the moon. They just count the photons, and as you can see, sometimes they count 900 photons, and the next day, the next month, when the moon is in culmination, they counted only 2 photons or no photons.
So the horizontal axis is the months of the year.
Yes.
Okay. What is the other curve? You have 2 curves which are highly correlated.
The other curve, that was my calculation, but just by adding the displacement which occur by the velocity, by the different velocities of the Earth through the universe.
Oh, fantastic. That's amazing. Okay, thank you.
Okay.
And to boot,
that's really an amazing result you have there.
Yeah, exactly.
In your 3-dimensional depiction, one of the axes is the months. The other sort of horizontal axis, is that the observations, the number of observations?
Yes, the number of photons that come per day or come per month. Yes.
Okay. Okay.
And
Well,
therefore,
my work in binary mechanics suggests, especially in my analysis of inertial propulsion phenomena, suggests that there might be an absolute direction, not only an absolute frame, but also an absolute direction. And it seems to me your data is suggesting that at least agrees with that idea to some extent.
well, it's more complex because I thought that I could compare or I could take the displacement from the velocity of the Earth in the direction of the dipole Microsoft background. But
the CMB background, yes.
Yes, but then I realized that because of these many peaks, various directions are necessary to explain this complex pattern, which one can see in the data.
Okay, well, I'll look for your paper on papers on ResearchGate. You seem to be having done some very imaginative work. Thank you for your presentation, Hans.
And I think if you Google Hans Deyssenroth, maybe lunar laser ranging, you'll get a couple of other options for his papers.
Yeah.
Okay. So thank you very much, Jim.
Hillary Publishing. Okay.
I've seen a couple of references to your papers, so people might wish to do that. Okay. The time is catching up on us. Let's see. Actually, Bob Gray had a number of questions. He seems to have left. I don't know what they were. Let me just go back and see what they were. I know he didn't seem to have technical matters. Okay. Yeah, well, I mean, Jim has come back and he says, how does the velocity of the Earth with respect to the universe affect the intensity of the reflections of lunar laser pulse? But you seem to have shown, Hans, that when you took into account the final omitted velocity, in other words, the one towards the great attractor, I think, it seemed to give all these correlations.
Yes, exactly. Yeah.
Right.
But it does not, excuse me, to answer the question, the velocities do not influence the reflections. But what I would like to show is that the photons do not appear in the detector, which is near to the laser, but that the photons are sent to this place where the detector was 2.55 seconds before. But the reflection is not influenced by the velocities of the Earth and the universe.
Okay, so it does not affect the intensity of the reflections, for example.
Yeah.
Okay. All right, I'm just trying to see if there are any last minute questions that we can deal with. Raycar wanted us to show a video, 7 minutes video. I wasn't even sure what it was, but I don't think we have time now, unfortunately. We have to wrap up. We have time for one or two more technical discussions, but I also have a little administrative function to undertake now first. So it only takes about 2.5 minutes. Perhaps I'll do that now. And if we have time for one or two more questions, we can deal with them. So it's basically a boring thing, not equivalent to the sort of very interesting science we're talking about now. It's about the future funding of the CNPS and the fact that we run these shows every Saturday and so on. In my case, every second Saturday, and we have a shortfall between the funding which comes in from membership dues and the operational costs of running the organization, unfortunately. So with your permission, I'll just play a brief video recorded by the president of the organization, David DeHilster.
Hello everyone, I'm David DeHilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CNPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system. Several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Okay, well, thank you for your attention. My apologies for moving to a more mundane subject. Now, so what I'm endeavoring to do is to invite Hans to come back and, give up to a few minutes to summarize, the paper and the response and maybe some of the questions and how we might go forward. And then I'll officially close the meeting. But before doing that, there might be time for just one more question or comment that one might wish to put to Hans. So does anybody in the social media wish to raise one last issue that hasn't been raised already? Or indeed anybody in the green room wants to come back just for a minute or two with one final point. I think you're all quite happy with Denny does want to come back. Yeah, we have time for one more point, Denny. So go ahead.
Yeah, J.P. Wesley in his book Scientific Physics has some experiments done by I can't think of his name, but it shows that the velocity of the Earth through the universe can be measured. I think this is maybe your great attractor idea. I don't know, but he gives several different ways that this is measured, and one of them is I can't think of the guy's name, but he had a coupled mirrors experiment.
Oh yes.
What's his name, Ian?
That wasn't Silberstein, was it?
No, it was.
Yeah, was it Marinov?
Marinov, yes.
Yeah.
No, wait. It was.
No,
I'm not sure it was Marinov. Well,
I do
anyway,
remember
it's
the bit in Leslie's book, but I can't remember.
Scientific Physics by J.P. Wesley. And he measured the velocity of the Earth through the ether. And like Hans, he broke it down into various things, the velocity around the sun, the velocity of the sun through the galaxy, and so on. And it's in Scientific Physics by J.P. Wesley.
So Hans, is any of that new to you, or are you familiar with some of it? What do you think of it?
Well, I mentioned that these pushing particles could cause gravity. And then imagine when the universe was very small, these pushing particles are next together, and then they can build black holes. We don't need Einstein for explanation for black holes, but these pushing particles could build black holes, and the black holes are then there before the atoms were here. And therefore, a galaxy can be built much, much earlier. And this was confirmed by the newest recordings of the James Webb telescope. So this is a nice confirmation of this, of this theory with the pushing particles. And there's another very interesting fact that was measured recently by astronomers. The black holes can grow without matter. They have no matter anymore to swallow, but they are growing. And this is only possible if pushing particles get stuck in them. And so these things cannot be explained by the general theory of relativity as well. So we have many hints that we should reactivate the idea of factor de Dewey, but we should regard the elementary particles as huge structures and not as small balls or as points as it is done in the quantum theory. And by the way, if we have structures that can oscillate or swing and such structures, the string theory would much more efficient, because the structures can only have a certain frequency and not arbitrary much frequencies. And one could only, I think it would be sufficient to use only 4 dimensions instead of 10 or 9. Okay, I think there is much to do to bring all together.
Yes, quite so. So thank you very much for that additional point, Denny, and reference to J.P. Wesley, whose books are quite illuminating. So thank you again. Now, so my final point, Hans, is to give you a couple of minutes or more, if you wish, just to summarize, what you've been saying, the questions and the response and so on, and anything else you'd like to say in regard to our discussion. So I'm going to disappear, and I'll come back then and officially close the meeting.
Well, there are many hints that the existing theories of relativity are wrong, though there are many experiments which show that they are right. And Einstein said once, as far as I know, one experiment would be sufficient to crash down the whole ivory tower of theories. And the problem is that many people work with the space-time and with these formulas of the relativity. And we should find other model that could provide about the same formulas or the same, but with another model that we can understand physically. As I said at the beginning, a mathematical model with a wrong physical mechanism or process is misleading, leads to wrong conclusion, and now it is like a big ocean liner that moves in the wrong direction. And I, as a nobody in physics, I cannot stop it. But I hope that when time goes by, some youngsters could develop another theory than the existing theories that we have. Okay, thank you.
And thank you, Hans, very much. We are certainly indebted to you for having come today and prepared most impressive slides and spoken very well to your subject. And I know that the papers you have there in the public domain will help anybody who wants to delve further into this question. I think the discussion today actually has been quite stimulating. We've had a lot of comments and questions coming in on the social media, and we really haven't had time to deal with them all. Some of them were more conversational, but there are things to be taken up at a later stage. And we had a small attendance in the green room, but thank you everybody, I think, apart from Bob Gray, who left early. Thank you very much for your contributions. They were very helpful. As I said, Hans's point there about one sole voice singing, crying in the wilderness or whatever, getting forward. Well, as I said a few weeks ago, we're all perhaps chipping away at a monument, which maybe is only made of stone, and if there are enough chips in it, it will eventually collapse. And for my own part, I think that although there is thriving the practice of cancellation and censorship and all that, I actually think I see a little more light in the tunnel in regard to what we're doing now than I might have seen a generation or more ago. I think it's beginning to be some questions that are a bit harder to answer now. But I think it's going to take some time before perhaps we've sown enough doubt in the minds of people to find that it's something irresistible, and we have to review these theories which have been accepted as gospel for 100 years and more. And I think I think Hans has made an invaluable contribution to that today in giving his take on this whole question of lunar ranging and the experimental results he has obtained. So on behalf of you all and on behalf of the CNPS, I'd like to thank him very, very much for all the trouble he's gone to in providing his presentation and in talking to it so eloquently today. And I'm delighted that we've had such a stimulating talk as the first one for 2025, which hopefully will set us off now on a program which will prove to be successful for the coming year. So again, I'd like to thank you all and thank Hans very, very much. And I'll close the meeting now. I'll close the recording. The recordings, of course, will be available if you want to look back on them. They're available on the YouTube of the CNPS, and you can Google it. You'll find them. So I'm stopping everything now, and I wish you all, wherever you are in this cold world anyway, here, middle of winter, a very good day.